Hello, in this episode of Exploring Rusts, I'm going to attempt to explore generics. So I read through the documentation. It took me a while because I kept tuning out. And then I tried actually using generics because I kind of thought, well, this is really similar to Java or C++. And I found it really difficult to get any code working at all. But eventually I did get some code working. Then I deleted it and I tried to make a video out of it, and it just went extremely badly. So this is my second attempt at a video, having looked at the code that I previously wrote and tried to refresh my memory. So generics, of course, are a way of creating, well, not classes in this case, but functions and structs and enums that can work with different types of things. And apparently in Rust is just going to create actual different types of things for each type that you try to use the generic entity with, if you understand what I mean. So here I'm just going to start by creating a regular struct. So we could have, for example, x of type i32, y of type i32. There's no semicolon there because it's like a type definition. Then I could say let p1 equal point. And actually this could all be on one line. So let's say here x colon, no, hang on. I want to actually give a particular, what am I trying to do here? Yeah, I need to say x has the value of, let's say 1, and y can have the value of 2. And then there is a semicolon there. I think that's right. And then I can do print ln with an exclamation mark. And in double quotes, let's put p1 colon question mark. So this is not going to print out the box, I know that, but the error message I'll get from the compiler will tell me how to make it work. So let's try to compile this. Cargo run. Point doesn't, yeah, okay, I expected this. So I need to put this derived debug thing at the top right here, and then it should work. So let's try that. So we've got a point coming out right there. Now, at the moment, this point can only work with 32-bit integers for both of its fields, but we could make it work with basically any type by making it generic. So I could put the name of some type here, some unspecified type, which as in other languages is apparently often just a single uppercase letter. And now Rust is going to infer what type of thing this point works with. When I actually try to create points. But here I should put T, we should actually use these. And we could have different types for both fields. I believe we could have like TE or whatever, TS maybe. But I'm not going to attempt that now, that's a bit over ambitious for this stage of things, I think. Okay, right, I think that's right, let's try this. So I'm going to clear it and I'll run cargo format just to be sure, and cargo run. Yeah, so we've got our point, it's working just as before. But now we could create points of different types. So if I were to copy these two lines maybe, paste them in down here and have a point P2, and this can be 1.2 and this can be 2.3. So now we've got floats in there, and that should still work because it's going to infer this type from this stuff. So if I try that now, you can see that it still does work. Now I'm used to having to explicitly specify the generic type of a thing when I actually use it. And in my earlier run through of this, I didn't do that. But then while I was trying to record this video the last time, I had a go at it and the syntax really surprised me. So let's just try that. Let's have a P3. And well, this can be float again. So this could be like F32, for example. Let's print it down here. And if I want to explicitly specify the type, I think I have to put 2 colons there and the type goes here. So that ought to compile. Let's try it. Yeah, so it works. I don't know what the meaning of these 2 colons is at the moment, but if I try that, you know, like with integers or something, that's not going to work. I've already tried that. So now they really have to be 32-bit floats. It just really surprised me that there are colons here. I don't know what they're doing there, but I think that mystery will be cleared up shortly in a subsequent video very soon. Now, another thing that I can do is I can provide different implementations for different types, different associated functions. So if I write here impl, now let's try to get this right. I think I can specify a type. Yeah, I have to specify the name of the struct. And then here I could say that what I'm about to implement applies, for example, only to structs that work with 32-bit integers for this generic type parameter here. Now, if I do this, I can be sure that these are going to be 32-bit integers. So, for example, I should be able to add them together. So let's try to create a function called maybe sum, and that's got to take a reference to self if it wants to access the fields of this struct, and it's going to return, well, a 32-bit integer, and I should be able to do return self.x plus self.y, I think, and because it's Rust we don't even need this return keyword if we miss off the semicolon there. So then I should be able to use that. Let's maybe copy this, paste it in there, and so here I'm creating actually I could use one of my existing definitions. So here I'm creating a struct that indeed does work with 32-bit integers, and I should be able to print, let's get rid of this stuff and just call p1.sum and see if that works. So if I do cargo run here, yeah, that works, and we've got 3, which is the sum of those two fields. However, if I have a 32-bit float, for example, that is not now going to work. So if I try to do p2.sum, I'll get an error because this implementation only applies to points that are working with 32-bit integers here. So I expect that not to work. Let's try it. And if I run it, yeah, it actually says point float is not an iterator. I don't know why such a strange error message. I have no idea what iterators have to do with this at all. But anyway, so I should be able to supply a generic implementation as well. So let's copy that, paste it down here. And now suppose I have an implementation that works with some generic type t. Not the same type here necessarily, but I'm going to say that it is going to be the same type. So I'm going to put t there and t here. Except the thing is, what do I know about x and y now? They're going to be of type t. I don't know whether they can be added together, for example. I don't know what they can do. So I can't easily implement this. I believe that it could be implemented by supplying trait information. I'm getting the idea that traits are kind of like interfaces in Java. You can use them to add functionality to things, and you can also specify what functionality things have. But I'm not really sure how to do that at the moment, so I'm going to change this. Let's have a function called x, and that's just going to unambitiously attempt to return x, which has got to be of type t, and let's actually make it a reference to x as well, since that ought to be more efficient, I would think, slightly, maybe. And now, okay, I can't do this, but I would think I could do this. I could just invoke that function, which will work with any old type, basically. So let's try that. Clear this screen here, cargo run. Yeah, that doesn't work, but I forgot self here, didn't I? So let's put self.x and try again. So, yeah, now it works, and I've successfully returned the value of x. So that's about the sum total of my knowledge of generics and structs at the moment, but I can also show you generic functions. So I'm going to create a function down here, which I'll call add, and that's going to take x, which initially, let's make it of type i32 and y of type i32 for simplicity, and let's say that it returns an i32. And I'm just going to return x plus y. And then I should be able to call this function down here and do something like print line, and here I can put a couple of brackets and add, and we should be able to add a couple of numbers together like 7 and 8, which should be, what, 15. So let's try that. So when I run this, yeah, that works. We've got 15 coming out there, but I should be able to make this function generic. So I think the type parameter goes right after the name here. So I'm just going to stick to using one type again, although I could presumably put, TS or something and have these of different types. And then X is going to be of type T and Y is going to be of type T, and we're going to return something of type T. Now, here's the difficult bit. Because these parameters are of generic type T, we don't know if they can be added together. So we get an interesting error message when we try to run this, assuming I've even got everything in the right place. Let's try it. So here's the error message that I get. And it says, consider restricting type parameter T, because you cannot add T to T. And it suggests adding all this stuff in. So I'm just going to copy that, and let's go back and paste that in right there, and then try it again. So if I clear this and do cargo run, now it actually works just as before. So what this is, in my understanding, is it's some kind of trait specification. I might be wrong, so don't take my word on this, but I think we've got an add trait here, and we're also saying that this add trait specifically, when we do the addition, will return something that is also of type T. So this is going to return something of the same type as these two things in this case, which is going to be this type, which it gets inferred when we do this. I don't know if I could specify here : I32. Let's just try it out of curiosity. I haven't tried this previously. Yeah, that does work, look. So I guess that is the right syntax for doing that. But that's it for this video, and next I'm going to read through the next page, which is on traits, and I can see why traits and generics are in the same section now, because you're very limited what you can do with a generic type without bringing traits into it, which specify what you can actually do with those types. So next time, after reading the next page in the docs, hopefully I'm going to be making a video on traits. So until next time, happy coding.